Okay, let's take a look at another example for this topic. Okay, a closed cylindrical can of radius r and height is to have a volume of 128,000 centimeter cube. First, you need to show that the surface area is A is as such, and next find the radius that minimizes the surface area. So right now, this is a closed cylindrical. Okay. And then the radius is r and the height is given as h. Okay, now first thing that we need to do is to extract the information that we have, right? So what we have is an information that the volume is actually 128,000 centimeter cube. Therefore we will actually optimize this question by using the volume formula for a cylinder. So the V is pi r squared h. Pi r squared h is equal to 128,000. Therefore, h is 128,000 over pi r squared. Okay. And the formula for A is 2 pi r squared plus 2 pi r h. Note that this we use 2 pi r squared because this is a closed cylindrical can. If it is an open cylindrical can, that means here will only be pi r squared. Okay, take note of that. Okay, next 2 pi r squared plus 2 pi r, we substitute the equation for h here, and hence we have A equal to 2 pi r squared plus 256,000 over r. After we simplify this equation, that means cancel out pi r. Okay, so this has been shown. Okay, now please take note, why do we need to do this is because we want to minimize the surface area. When you want to find the minimized surface area, that means you need to have the equation of A in terms of R probably. Why? Because you want to find the radius. Okay, so right now, next what we do, we have A equal to 2 pi r squared plus 256,000 over r, which can also be written in terms of this. Okay, the reason I write it in terms of this because it will be easier for you to differentiate this part later on. Okay, so now we have dA over dr, which is 4 pi r minus 256,000 r power of negative 2. Okay, next what do we do? Okay, I missed one step. You actually need to write dA over dr equal to 0, and hence we have 4 pi r minus 256,000 over r squared equal to 0. Rewrite it in terms of positive index back because it will be easier for you to solve the question later on. Okay, right now solve for the value of r. Okay, rearranging everything in the equation, we will have r equal to 27.3114 centimeter. Okay, although you have only one value of r or x or h, you still need to do the second derivative test. This is compulsory. Second derivative test is compulsory. Okay, so right now differentiate dA dr with respect to r. We have 4 pi plus 512,000 r power of negative 3. Okay, which can also be written as 4 pi r plus 512,000 over r cube. Okay, so right now substitute the value of r in the second derivative. We have this value 368.34, which is larger than 0. Okay, remember when this test value is larger than 0, that means it is minimum. That means A is minimized. Okay, that's why therefore A is minimum when R equal to 27.3114 centimeter. The reason we write this conclusion because the question itself asks us to find the radius that minimize the surface area. Okay, that means the surface area is minimized when R equal to 27.3114 centimeter. Okay, next. the third example. We have a closed rectangular container with a square base that is to have a volume of 2250 centimeter cube. Okay, take note, closed rectangular container, okay. The volume is 2250 centimeter cube. Okay, and the material for the top and the bottom, okay, let me sketch a container, perhaps a box. Okay. Okay, the material for the top plus bottom would be, the cost is actually RM2, and then the material for the sides is RM3 per centimeter cube. Okay, find the minimum cost of constructing the box, to construct the box. Okay, so right now, the information that we have is this, and this is the closed rectangular container with a square base. That means here is X and X. You may use H, but I prefer to use Y because I have used X. Okay, so right now, V is actually X squared times Y. Length times the width times the height. Okay, V equal to X squared plus Y. So next we have 2250 equal to X squared Y, which we have Y equal to 2250 over X squared. It will be much easier to have our equation in terms of X, because if you let here X as the subject, you will have the equation in terms of 2250 over Y, and here would be root. Okay, it will be much easier for us to do it in terms of X rather than Y, because it won't involve radical. Okay, so right now we need to construct the minimum, the cost for the box. Okay, so C, RM2, that means 2 is for the top and bottom. So what is the surface area for the top and bottom? As you can see here, for the bottom it is X squared. That means for the top is X squared too. So right now we have 2 ringgit times 2x squared plus, okay, the size is 3 ringgit. But here we have, okay, for the sides, we have the first one is xy, and then the next one is xy2. Okay, therefore, here is actually 2xy, and the next one, for the next side, is actually xy, and here is xy also. Here we can conclude that we have another 2xy, and constructing the equation, we have here 4x squared plus 3. 2 plus 2 is 4. 4 times 3 is 12. X, Y. Substitute Y that we have obtained earlier. 4x squared plus 12. X times 2250 over x squared. Here we have actually C is equal to 4x squared plus 12 times 2250. Let me calculate for a second. Sorry. 12 times 2250 is actually 27,000. So here would be plus 27,000. And this one can be cancelled out over X. Okay, this is the equation for X. Next, we want to find the minimum cost. That means we need to differentiate the cost. Okay, we want to find the minimum cost, we need to differentiate the cost. So right now, dc over dx. Why dx? Because c is in terms of x. Okay, first, rewrite this in terms of the equation that will be easier for us to differentiate, which is this one. Okay, next. 4x squared is 8x minus 27,000 x power of negative 2. So next, dc dx equal to 0. So 8x minus 27,000 over x squared equal to 0. So let's rearrange and solve for x. Next will be 8x equal to 27,000 over x squared. So x cubed equal to 27,000. X is equal to 27,000 divided by 8 root of 3, which is okay, let me calculate for a while. 27,000 divided by 8 root of 3. This should be x equal to 15. Remember, although we have one value, we still need to do the second derivative test, which is d squared c over dx squared. Okay, let's recall dc dx that we have here. 8x minus 27,000 x power of negative 2. So 8x would be 8 minus would be plus 27 is 50,000 x power of negative 3. Next, d squared c over dx squared when x equal to 15 is equal to 8 plus 54,000 over 15 cube. Okay, 8 plus 54000 divided by 15 cube. 24. Okay, 24 is greater than 0. That means this is, the cost is minimum. Okay, the cost is minimum. Remember, this is only test value. Okay, test value. Okay, next, therefore, cost is minimized or minimum. You can say minimized is minimized when x equal to 15 centimeter. Okay. And then we need to find the minimum cost actually. So what is the minimum cost? Okay, refer back to our equation for the cost, which is this one. Okay, c is equal to 4x squared plus 27,000 over x. So here we need to calculate for the cost, which is c is equal to 4x squared, okay, plus 27,000 over 15. That is equal to 4 times 15 squared plus 27,000 divided by 15 is actually 2,700. So the cost is actually Rm 2,700. Okay, that's it. Okay, thank you. Hope you have a glimpse of what actually you need to do to solve and apply maximum or minimum problem. Okay guys, thank you. Assalamualaikum.